The accompanying graph describes the motion of a toy car across the floor for 10 seconds. What was the total displacement of the toy car for the entire 10-second interval shown? So remember that on a velocity versus time graph, displacement is the area under the curve or under the graph. More accurately, it's the area bounded between the graph and the time axis. So, for the first part of this object's journey, it's traveling in the negative direction, meaning that it'll have negative displacement. And then for the second part of the object's journey, it's traveling in the positive direction, meaning that it will have positive displacement. So if we sum the negative and positive displacement, we should find the total displacement of the toy car for the entire interval. Okay, so let's divide these big areas into smaller areas that are easy to calculate. So here we've got two triangles and a rectangular segment, and here we'll have this big triangular segment, a big rectangular segment, and a smaller triangular segment. So now if we find the areas of all of these segments and add them all together, we should get the total displacement for the entire 10-second interval. So first we're going to start left to right. So this area of this upside down triangle, maybe I'll even try to draw it like so. It's going to be 1/2 base times height, where the base is kind of obscured here. It's kind of hard to see. This is 2 seconds. So the base is 2 seconds. So we have 1/2 times 2 seconds times the height, which is -1 meters per second. -1 meters per second. Now if we multiply these together, we'll get an answer of -1 meter. Next we'll look at the area of that square-ish section. So its area is going to be length times width, where one of those dimensions is going to be 1 second, since the difference between 2 seconds and 3 seconds is 1 second. So it'll be 1 second times -1 meter per second, which is equal again to -1 meter. Next we'll do the area of this other triangular segment. So it looks a little bit more like that. We'll do 1/2 base times height, where the base is the difference between 3 seconds and 4 seconds. So again, it'll just be 1 second. So I'll have 1/2 times 1 second times the height, which is again -1 meter per second. So this will be a displacement of -1/2 of a meter. Okay, now let's look at the positive displacements. So we have first the area of the triangle that looks like this. It'll be 1/2 base times height. So 1/2 the base, which is 2 seconds, the difference between 4 and 6, 1/2 times 2 seconds, times the height, which is 2 meters per second. And this is equal to 2 meters. Next we'll look at the area of the rectangular segment. It looks a little like this. Its area will be length times width. The length is from 6 seconds to 9 seconds, so it's 3 seconds. And the width is from 0 meters per second to 2 meters per second. So it'll be 2 meters per second. This is equal to 6 meters. And then finally the area of the last triangular segment, which looks like this, is also going to be 1/2 base times height. The base is just 1 second. The height is 2 meters per second. And so it'll be a displacement of positive 1 meter. Now if we add all of these together, the total displacement is going to be negative 1 meter minus another meter minus half a meter plus 2 meters plus 6 meters plus 1 meter. So if you add all these together, you should get a final answer of negative 1 minus 1 minus a half plus 2 plus 6 plus 1, which is 6.5 meters in the positive direction. So that is the answer to this problem. The total displacement is 6.5 meters across the 10-second interval.